Hello guys and welcome back to another video assignment, and my name is Paranit. I'm studying Sri Venkateswara College of Engineering, pursuing my 7th sem in the field of computer science engineering and artificial intelligence, and today we are going to be talking about the topic WebSockets and Internet of Things. This presentation will dive into the world of WebSockets and how they revolutionize the way we design and implement Internet of Things applications. We'll explore the benefits, architecture, and challenges of using WebSockets for real-time data communication in IoT environments. By the end of this presentation, you will have a comprehensive understanding of how to leverage the power of WebSockets to build robust and responsive Internet of Things systems. Introduction to WebSockets. A WebSocket are a persistent bidirectional communication protocol that enables real-time data exchange between a client and a server. Unlike traditional HTTP requests, which are initiated by the client, WebSockets establish a precision connection that allows data to flow freely in both directions, as it is a powerful communication tool. Breaking the barriers of traditional HTTP, WebSockets enable a more efficient and dynamic communication flow, as data can be exchanged continuously without the need for constant requests. This eliminates the latency associated with HTTP requests and opens up new possibilities for building interactive and responsive applications. Benefits of WebSockets for Internet of Things. Real-time data communication. WebSockets allow for instant data exchange, making them ideal for applications where real-time information is crucial. This enables immediate responses and updates regardless of whether the data is being sent from a sensor, actuator, or a mobile device. Reduce network overhead. Since WebSockets establish a strong persistent connection, they eliminate the overhead associated with establishing new connections for each request. This reduces network traffic and optimizes resource utilization, especially in resource constrained IoT environments. Improved scalability. WebSockets can handle a large number of concurrent connections, making them well suited for large scale of IoT deployments. The ability to scale efficiently is crucial for handling the increasing volume of data generated by interconnected devices. In this slide, we get to know the main reasons why we are using WebSockets, as it improves scalability, where it is able to handle large amount of connections, and real-time data communication, as it allows better flow of data from one to another, and as they have a strong establish a strong persistent connection rather than the HTTP request, we will be able to eliminate the overhead associated with establishing new connections. Real-time data communication, sensor data streaming and automated control and instant notifications. WebSockets enable the seamless transmission of sensor data from services to a central server. This facilitates real-time monitoring and analysis, enabling proactive responses to environmental changes for device malfunctions. Automated control. WebSockets allow for the real-time control of actuators based on received data. This enables automated responses to sensor readings, user inputs, or predefined conditions, empowering the creation of intelligent and reactive IoT systems. Instant notifications. WebSockets enable instant alerts and notifications to users based on specific events or data thresholds. This allows for timely intervention and improves the overall user experience by providing real time feedback and proactive communication. Reduced network overhead. Reduced latency eliminates the delay associated with establishing new connections for each request, leading to faster responses and improved user experience. Optimized bandwidth minimizes the amount of data transmitted over the network, leading to efficient resource utilization and reduced costs. Enhanced battery life reduces the energy consumption of devices by minimizing the number of network requests, especially important for battery powered IoT devices. And improved scalability, multiple device connections. As we discussed earlier, WebSockets can handle thousands of simultaneous connections, making them ideal for large scale IoT deployments with high density of connected devices. real-time data aggregation, efficiently handle the massive amount of data generated by connected devices, allowing for real-time aggregation and analysis of data from multiple sources. Distributed architecture. WebSockets can be integrated with distributed architectures, enabling seamless communication between devices and servers, even in geographical diverse locations. WebSockets architecture and IoT. Client device. The client device, such as sensor, actuator, or mobile application, initiates the WebSocket connection and sends the data to the server. The server receives the data from the client, processes it, and sends responses back to the client through the established WebSocket connection. Message broker. An optional message broker acts as an intermediary between the client and server, enabling asynchronous communication and facilitating scalability in large-scale IoT systems. Challenges and best practices. Security. Ensures secure communication by implementing appropriate authentication and encryption mechanisms to protect data exchanged over WebSockets. Scalability. Designed in the architecture to handle a large number of connections and data throughput, considering load balancing, message queuing, and distributed server infrastructure, and mainly used where there is large number of data to be handled and connections and requests. Error handling. Implement robust error handling mechanisms to detect and manage network interruptions, device disconnections, and other potential issues, ensuring reliable communication. And that is the end of the video, guys. And if you have found anything useful information, please leave a like. Thank you.